Hi students, we're going to start our Vodcast 1.5 today, and we've really got a couple of pretty important things. The first thing's pretty simple, percent error, but conversion factors are where we really get into the meat of what is chemistry. So you really want to make sure that you pause, take notes, get everything you possibly can from this video. It's probably the most important all year so far. So percent error, basically what percent error is a pretty simple formula. And a type of problem that we'll be doing pretty often, especially in labs, because what it does is it tells us essentially how accurate a measurement that we took in the lab is, how close it is to the real thing. We talked about accuracy and precision before. Percent error gives us a number to put with that rather than saying it was accurate or wasn't. It says it was this far away. So the formula says that the percent error is equal to the observed value, that's what you measure in the lab, minus the true value. The true value is the actual value of that thing. So like if we're measuring the density of gold, we know that the true value of the density is 19.3, but if we measure it in the lab to be 18.9, then the 18.9 is our observed value. So again, it all goes back to the idea of accuracy. So we're going to work a little sample here just to see how this works. It's pretty simple. We'll work through several of these in class. So here's the question. After doing a lab, your weighed sample has a mass of 28.4 grams. Immediately, you should go in on that. Whenever it says or it actually is what you measured in the lab, that's the observed. Okay? Your instructor tells you that the actual mass should be 30.2 grams. What is your percent error? So that 30.2 then, that's the actual or the true value. Okay? You have to have both of those things. Once you have both of those things, then the actual calculation is pretty easy. So we're going to write down our formula. Okay, that percent error is 28.4. That's our observed minus 30.2. Okay, that's my true. And then we're going to subtract that. We're going to divide all that by 30.2 grams. Again, you'd always divide by the true value. And then we're going to multiply that by 100. Now make sure when you put this in the calculator that you don't actually hit the percent key at the end. You're just going to multiply it by 100. Okay, if you put the percent there, the math is going to go all crazy on you. Okay, so we're going to punch that into the calculator. As usual, we're going to get a weird, big, giant number that we know isn't right. That's okay. So in this case, we got negative 5.960264,901. We know that at this point in the year, we know that how we're going to round those numbers then is to significant figures. Now the good news is both of my givens have three significant figures. 28.4 has 3, 30.2 has 3. So if both my givens have 3, then I know my answer should have 3. So what we're going to do then is we're going to round that to 5.96%. You can have a negative or a positive sign. That negative means that I'm below what the actual value is. Okay, we're going to talk about equalities now. This is the super mega important part. This is the beginning of conversion factors. Essentially what an equality is an equality is simply two things that equal each other. I mean, that's what equality means. So like 1 dozen of something is 12. 1 pair is 2. One that you're probably not as familiar with, 1 score is 20. That's like from Abe Lincoln's 4 score and 7 years ago. Score is 20. 1 gross of something is 144. That basically means a dozen. Those things are what we call equalities. And in this case, the 12, the 2, the 20, the 144, they could be of anything. We would think it's like a dozen eggs, but it could be a dozen donuts. It could be a pair of shoes. A gross of eggs is pretty common too. It could be of bananas. My favorite example. It could be of stars. It could be of cars. Not to get too Dr. Seuss with the rhyming there. And of course, my drawing skills are amazing, so that's like a rocket car apparently. But the point is, it could be of anything. So those two things are equivalent. You've got a dozen, and it's equal to 12. In measurement, this happens a lot. This is how we do most of our conversions. So we know that 12 inches equals 1 foot if we were using traditional measurements. We also know that 3 feet equals 1 yard. The yardstick that you might have laying around the house is 1 yard, and that's not to be confused with a meter stick, which is actually a little bit bigger than a yard. We also know that 5,280 feet is equal to 1 mile. Okay, these are equalities. I've got one type of measurement on one side of it and the other measurement on the other side. And you'll see pretty quickly how this is going to lead us to conversions. If we were going to do some non-distance measurements, we could say something like 1 gallon equals 4 quarts. We could then say how many quarts are in a pint. So in this case, we got how many pints are in a quart, rather. So 2 pints equals 1 quart. And then so what's a pint? Well, we then know that 2 cups equals 1 pint. These are all, again, just equalities. They're 2 different measurements, 2 different types of measurements that are equal to each other. And this is the key to all the calculations that we're going to do in chemistry. A good example of some of these in SI terms, because since we do most of our measurements in SI rather than in those traditional units that we just talked about, the SI equalities are going to be really important to us, or the metric equalities again. And we worked some of these out the other day. You have some of these on your conversions sheet that we did. So we know that 1,000 grams equals 1 kilogram. We know that 1,000 milligrams equals 1 gram. These are things that we're going to use constantly in this class. We know that 100 centimeters is a meter. We know that 1,000 milliliters equals 1 liter. And again, these were actually things that we did in class on your in-class work on the measurement section on the SI system. As we figured out what some of these were, you probably wondered why we had all these equal things here. Those are equalities. This is how we're going to do conversions most of the year. So that leads us into, if we know what an equality is, then what is a conversion factor? So to do that, we're going to take one of our equalities. Okay, it really wouldn't matter what one. You could use any of them. I'm going to use one of, initially at least, one of your traditional ones, just because it's something that you might have some knowledge of, from home. Everybody's got a gallon of milk in the fridge. So to make a conversion factor, basically you turn the equality into a fraction, okay, a ratio. And for every equality, you can do it in 2 ways. So we take our equality, 1 gallon equals 4 quarts. We could put 1 gallon over 4 quarts, or we can put 4 quarts over 1 gallon. Now, which one of those things that you have to do depends entirely on the problem. If I have quarts and I'm trying to turn them into gallons, I want quarts on the bottom. If I have gallons and I want to turn them into quarts, I want gallons on the bottom. For an example of a metric system one, we've got 1,000 milliliters equals a liter, and we'll use this one a lot in class. And we can, again, for every equality, I can make 2 conversion factors, or 2 fractions out of that. Okay, so the first one, put 1,000 milliliters on top, put 1 liter on the bottom. The other way is basically the same thing, just flipped around. 1 liter on the top, 1,000 milliliters on the bottom. So the trick here is to figure out which of the 2 conversion factors that you can get from a given equality do you need. And just again, real briefly to show how this works, 1,000 grams equals 1 kilogram. We can split that up into 2 different things, and again, this is a very common one that we'll use a lot in class. And so we can have 1 kilogram on top over 1,000 grams, or we could have 1,000 grams on top of 1 kilogram. Either way. And again, it is entirely dependent on what the problem is. So we're going to look at a problem here and see how to set this up. And obviously, as usual, work a bunch in class, but we're going to look at a problem specifically to see how this would work. The process of doing work this way, doing problems this way, is called dimensional analysis. That's why you see this title here. So here's our problem. You have 5 gallons of barbecue sauce. You need to put that barbecue sauce into quart containers. So how many quart containers do you need? Now I know, again, as we talked about earlier, I know what a lot of you are thinking is that I could do that one in my head. I don't need to work out some long, complicated problem. But remember, we want to start with the easy stuff to ease into the really complicated stuff later. So as with the problems that we've been working so far, here's what I want to write. I want to write down my given, and then I'm going to write down my unknown. So in this case, my given is 5 gallons of barbecue sauce. I know that I have 5 gallons. That's my given. My unknown is always what I'm looking for, and I always like to put a question mark and then the units of what it is, and that tells me what I need to convert. At this point in the year, it's not real important that you label, like that I put that it's of barbecue sauce. That will become more important later in the year because you'll have to say of what particular chemical, what formula, what compound do you have, and what are you turning it into. So here's the way this works. We're going to we always write our given with 5 gallons, and we always do this this little cross or box type structure to do these problems. You don't technically have to do this, but I think it's the easiest way to sort everything out. Your given always goes in the top left box, always. The box below it is either going to have nothing in it, or it might have a unit with a 1 in it. And we'll see some more of those later. So that's the setup. What we need now is an equality so that we can make conversion factors. Our equality is one that we did on a previous page. It's that 4 quarts equals 1 gallon. Okay? Remember, we can make 2 conversion factors out of that. So we're going to put it right here in the crosses. But the question then becomes, what do I put where? Well, you always put on the bottom whatever is in the given box, because you want to cancel that out. So since gallons are in the given part, I'm going to put in 4 quarts over 1 gallon. Okay, so here's what that's going to do for me. Dimensional analysis wise, dimensions are units, and so for analyzing them, we're going to be able to cancel stuff out. Now, mathematically, punch this into the calculator. 5 times 4, it's divided by 1 technically, but that doesn't matter. That gives me 20 quarts. And again, most of us could have figured that out in our head really quickly. So let's work another problem real quick, doing some of the conversion stuff that we did before using the staircase. We don't have to use the staircase. We can use equalities and conversion factors. And since most of the year we're going to do conversion factor problems that have multiple steps, it becomes really useful to be able to work it that way. So in this problem, convert 5.6 kilograms into grams without using the staircase. 5.6 kilograms is my given, grams is my unknown, okay? And my equality between those two things, and that's always what you look for in a conversion factor problem. What's the relationship between the given and the unknown? My relationship is that 1 kilogram equals 1,000 grams. Okay? So I start my conversion factor boxes. I put my given in the upper left, 5.6 kilograms, and then I'm going to take my equality, turn it into a conversion factor, and put it in the next box. Okay, now since I've got 5.6 kilograms as my given, I want kilograms on the bottom. So I take my 1 kilogram, that goes on the bottom. On the top then is going to go my 1,000 grams. That's the other half of the equality. Okay, then we're going to cancel units out. That's the dimensional analysis part. We cancel the kilograms, and we're left with grams on the top. That's good because my unknown is in grams. I want grams. So we punch that in the calculator and we get 5,600 grams. If you move this on the staircase, you would get the exact same thing. Okay, we're going to do a bunch of these in class, so hopefully that will make a lot more sense. Remember, dimensional analysis is going to tell us that our units are grams there at the end. Thanks, guys.